Next, we're going to draw the Lewis structure for diatomic oxygen. Again, two atoms. So we have the skeleton arrangement. Each oxygen has 6 valence electrons, so we're going to have a total of 12 electrons in this picture. Start by connecting the two atoms together with 2 electrons. Satisfy the terminal atom. Now it doesn't matter if you call the left the terminal or the right the terminal. Let's say we call the right one the terminal. The oxygen needs 6 more for a total of 8 to satisfy the octet rule. Then we try to satisfy the terminal oxygen, or central oxygen, next. And we're going to run out of electrons, because right now we've already used up 8. We only have 4 left over, and the oxygen on the left needs 6 more. So we can put number 1, number 2, number 3, and number 4, but then we run out of electrons. So now we're going to go to rule number 6, which is, if needed, rearrange electron pairs in order to satisfy the octet rule. In other words, the oxygen on the right is satisfied, the one on the left needs 2 more. We have to give the one on the left 2 more, but we can't add any more than our 12. So the solution is we move these non-bonding electrons and they become bonding electrons. So we end up with a double bond between the 2 oxygens. The oxygen on the left has 2 lone pairs, and the oxygen on the right has 2 lone pairs. Where you put the lone pairs doesn't really matter. Top, bottom, left, right, as long as you end up with 2 lone pairs on each oxygen and a double bond in the middle. Next, carbon dioxide. By symmetry, the carbon should go in the middle and the 2 oxygens on the outside. The number of valence electrons for the carbon is 4. And then we have to add 12 for the 2 oxygens. So that's a total of 16 electrons. We connect terminal to central. That uses up the first 4. And now again, we're going to satisfy terminal first. The one on the left needs 6 more electrons to reach 8, the octet rule. And so far we've used up 2, 4, 6, 8, 10 electrons. We can satisfy the oxygen on the right with number 11, 12, 13, 14, 15, and 16. So both oxygens are satisfied. However, the central carbon is not satisfied because it only has 4 electrons around it. And it needs to have 8. So we actually have 3 possibilities. We have 3 choices, 3 different ways that we can move electron pairs to satisfy the octet rule. One choice is move 2 electron pairs from the left and turn them into bonding electrons. If we do that, we'd end up with 1 lone pair on the left and then a triple bond to the carbon, and the one on the right is unchanged with single bond and 3 lone pairs. Choice number 2 would be, we could have done the same thing, but moving electron pairs, both of them, from the right. And we would end up with a single bond on the left and a triple bond on the right. Choice number 3 would have been to move 1 lone pair from the left and 1 lone pair from the right, and we'd end up with a double bond on the left and a double bond on the right. All 3 follow the octet rule. All 3 have the correct 16 electrons, and when you have choices like this, these are called resonance forms. And resonance forms are drawn with arrows that look like this, connecting the structures together.